Hello, ladies and gentlemen. If I could just give you an opportunity to take your cell phones out of your pocket, take a look at them, make sure they're not going to make any noise, because that would be really embarrassing if everyone in the audience looks at you while your phone goes off in the middle of a talk. So check those things. And with that taken care of, it's time to introduce our first after-lunch speakers today. Kate Heddleston and Joyce Jang are going to be teaching us about usable ops and how to make web infrastructure management easy. Please give them a fantastic welcome.
Hello. Is this on? Okay, perfect. Welcome to our talk. We're really excited to talk about usable ops, how to make your web infrastructure management easier.
So hi, I'm Joyce Jang. I'm a software engineer in the San Francisco Bay Area, and I currently work at an enterprise software company called Hearsay Social, which you may recognize the name of because a couple years ago in Montreal, we had a 30-foot blimp kind of hanging over the entire booth area. So you might recognize from there.
So my name is Kate Heddleston. I'm also a software engineer in San Francisco. You can tweet at me there, and if you get bored during this talk, you can go to kateheddleston.com/about and read everything you never wanted to know about me. So first, why are we giving this talk? The origins of this talk are actually non-technical. They go back to work that Joyce and I have done helping people put together engineering onboarding programs to train new engineers when they bring them on as new hires. So, onboarding is the process of taking someone from outside of the team or company and making them a productive, independent, and confident member of the team. And a few years ago, I started writing and speaking about the importance of onboarding, mostly for productivity, but also for diversity and inclusion. As a result of all of these blog posts and talks, I was brought into a bunch of different tech companies to help them put together engineering onboarding programs. So this was incredibly fun. I got to see a whole bunch of engineering process problems across a lot of different companies. Some were tech companies, some were actually not tech companies, some were big and some were small. What ended up happening was that a lot of the problems were not around how to train people, they were how to train people on the system that actually existed at those companies.
So at Hearsay Social, I've had the opportunity of seeing a company grow from a team of 30 to almost 200. And obviously, there are a lot of tricky and exciting problems that come about as your technology, product, and especially your team grow at that scale. But what was really interesting to me was that across all the technical projects that I took on and across the different stages of growth at the company, I realized some patterns in the main friction points that arose around these specific projects. So, for example, the friction points with scaling the technology was less about the actual implementation of this technology, as I originally believed, and more about the deployment and rollout of this new technology. And for scaling teams of engineers, it was less about bringing on as many engineers as you can, and more about building better automation tools so that you can scale the existing team, as well as when a new hire is onboarded. So as all these friction points manifested, they came about in various ways. However, there was an underlying theme across many of these cases.
So this is a really high-level diagram of a developer workflow. This exists across many companies, and it's existed for probably about 20 years, kind of Web 1.0 development. And so what Joyce and I found, her working at Hearsay and me working across all these companies, is that first, automation tooling was a huge problem for a lot of companies. But second, there was a specific pain point around deploying code out. So the actual infrastructure management tooling was one of the biggest pain points because deploying is a huge bottleneck for a lot of engineers and a lot of engineering teams. So deploying is often so fragile that teams have multiple teams internally to deal with this. There will be a DevOps team, and the application engineers actually throw their code over the wall to these DevOps teams to deploy it out. So there's an abstraction away from the actual problems that exist at these companies. And so when automation tooling and automation processes are unusable or complex, onboarding and training become very difficult. It's really, really hard to train engineers in a reasonable amount of time on a system that is too complex to learn in a reasonable amount of time, and even abstracting away these problems creates a bottleneck around those teams being the only point person for deploys and any question around deploys. And so as a result of this, my time consulting was half spent on creating the onboarding program, and the other half was spent doing an audit of all of their internal tooling to find all the ways they could make it easier to use so that people could actually be productive within their system.
So part of the problem lies in the way we think of web infrastructure. When we talk about web infrastructure and deploying code, we approach them as mostly technical considerations. However, in our experience, we have found that managing web infrastructure and deploying code is actually more about the human problems than the technical problems. So across all the problems that can and may arise in your engineering teams, most of the problems are due to bad team process and human errors. So what can we do about this? These are human problems that we're trying to solve, but these human problems arise when we try to interact with technology. Humans don't function the way computers do, and so we need to help ourselves by building the right abstractions in place so that we can optimize this interaction between us and technology. So in other words, we need to focus on building abstractions and putting in best practices that simultaneously allow us to do what we do best and computers to do what they do best.
So we wrote a talk, basically, on how to make your internal infrastructure automation tooling more usable for humans.
So today we're going to answer these 3 questions. First, what is usability? And then, why is usability important for web infrastructure? And finally, how do we build usable web infrastructure? And so we will focus today on more of the philosophy behind making your web infrastructure more usable for your teams. And we won't really focus on specific cases and list out all the different ways that you can make your specific setups more usable. We will explore a couple of examples in the end, but we want to focus on the philosophy, and that way you can better understand how you can take back these learnings to your teams and make your web infrastructures more usable for the rest of your team.
Okay, so first, what is usability? Usability is about how we interact with the man-made objects in the world around us. And to illustrate usability, I'm going to ask you 3 questions about how you navigate the world around you. So the first question is, how do you turn on a light? And this seems like a potentially easy question to answer. If we were to dim the lights in this room, how would we do it? I think there might be some lighting consoles back there. I'm not sure if we have a professional lighting person. That often happens. So Don Norman wrote a book called The Design of Everyday Things, and it's a very famous book, which I highly recommend, and we pull a lot from that book in this first section. But one of the stories he shares is that when he gave presentations, he loved asking someone at the beginning of his talk to dim the lights. And then he would stand there on stage and look really amused as people tried to find the correct light switch, turned off the wrong light, had to switch light switches. And it was to illustrate this point that turning on and off a light is not actually an easy thing to do. So turning on a light can be quite hard. You have to know where the light switch is, how to work it, and which light that switch controls. And if you go and Google Home Depot, or search Home Depot for light switches, you get over 150 results. There are over 150 different types of light switches that you can install in your home. So the second question is, how do you set your shower temperature? How many of you are staying in a hotel or an Airbnb and you're unfamiliar with the actual shower console? Yeah? How many people scalded themselves this morning? Yeah? How many people froze themselves this morning? How many people just nailed it first try? Yeah. And apparently most of you did not shower. And the final question, how do you open a door? So have you ever used a door incorrectly, pushed when you should have pulled, run into it, embarrassingly in front of all of your friends? And doors are kind of the canonical example of usability because there are several different types of door designs. We use them all the time. We need to be able to navigate them pretty easily. And these doors in the picture are trolls because you can't actually pull a door that has no handles, so I don't know how you would try to get through those doors. So this leads us to one of our key vocabulary terms, which is affordances. Affordances are how an object visually tells you what to do with it. So for a door, the way the door is designed should tell you how to interact with it, whether or not you should push or pull, whether or not you need to turn a handle. For a teapot or a mug, a handle affords holding, so it tells you that you should pick it up here. And affordances are a way to tell you how to interact with an object without having to label the object or put instructions on it. So mugs don't usually say hold here on the handle. That usually is an indicator that that affordance is not intuitive to people. And affordances aren't just about being able to visually see an object and understand how to use it. It's also about how people discover how to use objects. So if you have a set of silverware, a fork, spoon, and a knife, you could eat with your knife, but it's somewhat impractical if you have the other utensils there with you. You could also try to eat soup with a fork, but you should probably just use the single greatest utensil ever, which is the spoon, aka the food shovel, which is useful for pretty much everything. But you can actually discover how to use these objects simply by trial and error. So usability and affordances are all about making the right thing easy and the wrong thing hard, and giving people visual and tactile cues about how to use objects so that you can navigate the world without having to think really hard about it.
So what are the consequences of bad usability? So it depends on what you're talking about. It depends on what you want more or less usable. So in the example of the annoying doors, you can get frustrated or feel embarrassed, but in other situations, you run the risk of more severe repercussions such as injury or possibly even death. So let's take, for example, cars. Everyone knows that cars are quite dangerous and could potentially lead to death. So you can probably think about an intersection or a merge lane where there's a lot of accidents that happen. And not because there's so many bad drivers on the roads, but it's because of the usability of those specific roads. So our road infrastructure is important to the way our human societies work today. With so many cars on the roads these days, we rely on the usability of these roads in preventing these accidents from happening. So we are fully dependent on the usability of these roads to keep us safe from harm. So in 1953, after the post-World War II boom, there was an increased number of cars on the roads, and this increased number in cars led to more accidents. And so the Department of Transportation brought in engineer Albert Botts to oversee the research and invention of what became known as Botts dots. Botts dots are raised reflective dots that are put along lane markers. Before, painted lanes were difficult to see, especially at night and in the rain. With these Botts dots, people were able to see the lane markers, and that increased, their ability to see the lane markers increased dramatically, and therefore they reduced the number of accidents that happened. So what did Albert Botts and his team invent here, really? They didn't invent a new technology that made driving safer, nor did they change the rules of driving. Instead, these dots can be seen as a usability improvement. They make roads more usable for humans and therefore reduces the human errors and the subsequent traffic accidents that may result from it. Roads are an apt metaphor for web infrastructure. In the last 50 years, there's been a huge increase in the complexity of the roads and the number of people driving on them. Similarly, the complexity of web infrastructure and the number of people trafficking these web pages and building web applications has increased dramatically in the past 20 years. So road infrastructure needs to be reasonably learnable, understandable, and safe for the average driver to navigate. Likewise, building and using web infrastructure needs to be reasonably learnable, understandable, and safe for the average engineer to use.
Which brings us to our next section, why is usability important for web infrastructure specifically? So usability is all about how we navigate man-made objects, and I would like to clarify that software is a man-made object. It's very abstract and theoretical, but it is still technically a man-made object. Because it's abstract, however, it can be a little bit unclear how to apply a lot of the usability philosophies to software. So we're going to actually walk through an example of usability for something that many of us do every day, which is file editing. So a single person editing a single file has been a solved problem since about 1967, when the first screen editor was created. Screen editors became more widespread in the 70s, and We then came across the problem of what do we do when we have many people trying to edit many files over time? Enter version control. So the first version control system started showing up in the 80s. However, SVN wasn't written until 2000, and Git and Mercurial, hardest word to say ever, weren't written until 2005. So those are actually relatively new libraries. So even then, there are still issues with people collaborating on the same code repositories. So enter companies like GitHub and Bitbucket, and these are what I call developer productivity platforms. So these actually solve the highest level human problem, which is teams of individuals trying to edit files and review code over time. And this is a level that can finally be kind of plopped into this really high-level human workflow, just reviewing code in a general sense. And that's a pretty recent phenomenon. So the way that we develop and review code involves a lot of abstraction layers that have been built out over many decades to get us to the point where we can, as teams of engineers, review not only commits, but also large feature sets that are going to go out to test in production. So abstraction is, of course, one of the core tenets of computer science. It is the reason why complex systems like computing systems are even able to work. It's the reason that we don't code in binary or low-level executable languages. There's often human-readable language. And the final abstraction layer for any sort of stack is the human interface layer. So usability is the very last step in building any sort of abstraction hierarchy. And so a programming language's interface is going to be the actual language syntax. For an API, it's the way that you construct API calls and send over data and receive responses back. Interfaces can include the command line, it can include chat ops, it can include voice, text messaging. So pretty much any way that a human can interact with a computer system is technically an interface. So usability in software and programming is all about how humans interface with technologies and platforms in a way that makes sense to the human, not in a way that makes sense to the technology.
So what are the consequences of bad usability when it comes to web infrastructure? First of all, we have the technical repercussions. These are the obvious ones. You can lose data, your system can go down, etc. But what happens if you have dev tools that are too difficult to use? Let's take, for example, testing. Imagine a new hire joins the team where testing is set up in a way that makes it extremely difficult and complicated to add new tests. In this example, it's obvious that the new hire will have difficulties, but what about the existing team? How many of the existing engineers do you think are actually adding tests every chance they get and every chance they should? We engineers often pride ourselves on being the most efficient creatures at being lazy. So if dev tools are too hard to use, the engineering teams will most likely either avoid using the tools altogether, creating an expensive bottleneck in productivity, or try to use the tools and oftentimes use them incorrectly and make lots of expensive errors. So there's a funny story about Kate's brother Russ, who isn't here, so we can talk about him, by the way. And his very first internship at Trulia, back when the company was only 5 employees. In his first week at the company, he goes into the production database shell to delete one user and enters in delete star from users and hits enter. And so yes, he deleted the entire user database table. Fortunately, they had a backup and they were able to restore it. But the moral of the story here is that how engineers access and interact with our systems is extremely important. Human usable access points where engineers can make the changes they intend to make are very important features. In the example of Russ, what if there was a UI interface that allowed there to be some kind of form that makes data manipulations in the database? There can be all sorts of checks and balances, and maybe even auto-recovery in the event of errors. Or maybe it could also just explicitly list out the handful of cases that would be supported and safely exclude the possibility of deleting all the data. So we think about this kind of error-proof experiences for the users of our actual products. But it's just as important to take these into consideration when thinking about the endpoints that we make available for our developers.
The second repercussion goes back to the intro story about helping teams create onboarding programs. So one of the major consequences of poor internal automation tooling is an inability to scale your engineering team. So basically, you can't hire and train engineers in a reasonable amount of time if your system is too complex for them to learn in a reasonable amount of time. And I have a favorite story about this, and it is about a tech company that I will not name, that's about 5 years past its IPO now, I want to say, and they've actually had to halt hiring not once but twice for 6 to 9 months each time because every engineer that they added to the team was a net negative in productivity. So they were hiring senior engineers, and they required so much training, and their system was so hard to use that they would add a new engineer to the team, and that engineer would require more resources to get to productivity than the company had to offer. So they had to completely freeze hiring, which is really expensive. They had to actually build out kind of an internal infrastructure developer productivity team, devote resources to it so that they could fix their internal automation tools, put together an onboarding program so that when they hired people, they actually got an increase in productivity. And this leads us to one of the main points of our talk, which is if your system is too complex for your entire team to use safely, it is too complex, period. If new or junior engineers cannot safely use your system and they cannot learn it in a reasonable amount of time, the problem is not with the people, it is with your system. Since most developers understand the basics of how the web works, they understand that there are services that can send data to other services and then store data in databases, there's no reason why they shouldn't be able to safely interact with the system as a whole, to understand where their code is running and what is happening to it. And the way to do that is by having really usable automation tooling around deploys and how people actually access and use the system, so that they can safely interact with the web systems that they are building.
Another consequence when it comes to bad usability in web infrastructure is friction. As engineers, our success is often tied to the projects that we work on. And in the world of web applications, these projects are fully dependent on the web infrastructure on which it runs. So without accessible and understandable web infrastructure, application engineers are at the mercy of the engineers who actually do understand and maintain these systems. These conditions often make DevOps engineers appear to be gatekeepers, which makes this proverbial wall a lot more real and palpable and creates a clear division in the team. Whenever there's an us versus them dynamic in the same team, this is much cause for alarm. Especially when it comes to blocking each other's productivity, there's a risk of ugly power dynamics, demotivation, and attrition on the engineering team. These issues are sometimes accepted as normal team friction in our industry, but I strongly believe that most of this friction can be avoided. This friction is also not the fault of the application engineers or the DevOps engineers. We all understand that when it comes to software, there's a lot of complex pieces that are in play. And the way most teams have decided to manage this issue is through the separation of responsibilities, which I think is the right solution here, but it's only successful with the right abstractions in place. Okay, so we've talked a little bit about why making your web infrastructure more usable for everyone is important. But you may be thinking, what if I don't want to want everyone to have access to and make changes to every part of the system? And that's completely fair, and it's very valid, but it's also important to know that usability is separate from security. Just because everyone can use your system doesn't mean you have to give everyone access to it. So let's take, for example, the Norman doors that we visited earlier. Now, what if these doors were inside a building like the Pentagon? Building a security system inside the Pentagon does not mean that you want to make more complex doors for the more secure parts of the building. Security through complexity is the same as security through anonymity. It's not really security. Doors to the more secure parts of the building may have stronger locks and more access control, but if someone who has clearance to those parts of the building tries to go and use the door, they shouldn't have difficulty, and the door should still function the way any other door does in other buildings. A door that is too complex to use in the Pentagon or any other high-security building is still an example of poor usability. In other words, more complexity or poor usability doesn't actually buy you security, and good usability doesn't cost you security. Does having a door that makes you think you need to pull it in order to open it rather than push it to open it make the door the room on the other side of the door more secure? No. The ability to access the door is a separate concern than the usability of the door itself. So in other words, security is separate from usability.
Okay, so now that we have convinced all of you that building usable automation tooling is really important for your organization, we're going to talk a little bit about how you can think about doing this. So at the beginning of this talk, I asked you 3 questions about how you navigate the world around you. And now I'm going to ask you 3 questions about how you navigate your web system. So the first question is, how do you change system installations? How many of you know how to add or remove a system installation from a web service? So adding bcrypt, yeah, small handful. So usually changing a system installation is a completely separate workflow from actually writing code. And companies use tools like Chef or Puppet to manage kind of web services and their infrastructure, which is a totally separate process and also a totally separate tool that requires specialized training. So my recommendation is actually to use containers. Containers are a great example of a usability improvement in technology. So for any container naysayers in the audience who have concerns about the underlying technology, I'm going to ask you to suspend your cynicism for a moment while I explain why containers are a usability improvement. So first, containers fix one major problem, which is that system installations can now be changed the same way that code is changed. So if you've ever used Docker, you have a Docker file that lives in the root of your code repository, and that is how the container is built. So what this means is that if I want to go in and add an installation or remove an installation, I can actually go into the Docker file. If it's off of a Linux operating system, then manipulating the file system uses commands that I am familiar with. I can change a line of code, commit it, and push it the exact same way that I change any other piece of code in the system. And this is kind of mind-bogglingly nice. So I've used Chef in the past. I've built entire web stacks with Chef. And when I switched over to Docker, I was just like, oh my, thank goodness. Like, I'm so tired of having separate workflows, even though I understand both workflows in depth. Having one workflow is always better for humans because we're not particularly good at remembering things. So the second thing that containers do is they actually link system installations to code changes. So this is another mind-bogglingly awesome change for usability. So right now, if your system installations are run totally separate from your code, you can have orchestration issues. You could have the wrong installations running, or you need to make sure that everything is backwards compatible. This is a huge problem for humans to manage. But if your system installations are linked to your code and you want to roll back or roll forward, you can pick the container that actually has the correct installations, and they will be linked up to the right code. And this is also amazing, because humans spend a lot of time getting this wrong, and a lot of time trying to figure out why the servers are running the wrong things. Packaging it all up actually reduces a lot of human errors. So both of these changes, creating a uniform workflow for changing system installations in code and linking installations to code changes, are huge usability improvements for teams of engineers. So it greatly reduces the amount of information that a person needs to know to actually get their job done. I no longer have to go to Chuck, the DevOps guy in charge of everything, and be like, hey, how do I actually change a system installation? I already know how to do it. It also reduces the number of human errors because there are less things for humans to have to think about. And finally, it reduces the amount of specialized training that people need, which is huge because that is really, really expensive for you scaling your engineering team.
Okay, so next, how do you deploy your code? How many of you guys have kicked off a deploy? Awesome. How many of you have specific commands that you have to manually step through for this deploy? Okay. And how many of you have an automated script that you just kick off? Great. So as you all know, deploying code is important to the productivity of the team, and it's something that hopefully happens on a continuous basis. However, it can be the source of a lot of stress, anguish, and bad process. So what if you could deploy code with a click of a button, like this button here? One-click deploy system is one of the easiest ways that a team can improve usability in their internal tools. Deploying is much better with the click of a button because, first of all, everyone knows how to use a button. There's no training involved. If you want to teach someone how to deploy something, all you have to do is make sure they know how to use a button. And this way, you can focus on making sure that the engineer knows exactly what is being deployed and to where. And this way, the focus is on the intention and not the process details. So anytime you go in to deploy something, you don't have to think about all the manual steps that are involved in the deployment. You just think about what am I deploying and to where, and do I want to do this now? If so, press the button. If not, don't press the button. So by automating away as much of the technical functionality as possible, people don't have to worry about how the code is being deployed. So more generally speaking, abstract the pieces that require human intent away from the pieces that can be automated. For example, processes like code deploys. Server creation and failovers should also be automated as much as possible. And actions that require subjective human intent should have exposed endpoints, like a button, that allow people to trigger these processes. For example, actions like kicking off a deploy, or rolling back code, or scaling resources. So in other words, build good abstractions in general. Usability in web infrastructure highlights a lot of what computer science embodies. The appropriate levels of abstraction and complexity, kind of like the reason why we don't code in binary these days. So for web infrastructure, good abstractions are all about creating human usable entry points to your system. For example, at Hearsay Social, we have a tool that we called PRBot, and this is a collaboration tool for the use of deploys. Here, we list out all the different PRs that are open, and as the merge window opens, you go in to merge the specific PRs that you want. And as you can see, we do have buttons, and what's interesting is that these buttons will turn green as the PRs do get reviewed and as they pass tests. So the engineers know exactly what they want to deploy for the specific deploys. And also in a separate view, we also have a button that allows you to revert in case anything goes wrong in the staging environments. But what's really important here is that not only is it very clear to the engineer what exactly you are merging in the specific deploy, but it's also clear to the rest of the team about what is happening to your system.
So the final question is, how do you know where you are in the system? So when you're working as a developer, how do you know what piece you're working on and how it fits into the larger system as a whole? So is it an abstract spatial concept that lives in your head, where you know some pieces, other people know others? Are there parts of your system that only a few people know about and others don't? If you work at a company that has a lot of services, and there are companies that have more services than engineers, so you're starting to talk about 600 plus services, answering the question, where am I in the system, is non-trivial. So my advice here is to build navigation and collaboration tools. So the companies with the best internal tooling, and I've talked to a lot of companies that do have great internal tooling, have web applications, or developer productivity platforms, that allow them to review and deploy code changes in their own systems. So these internal web applications should also have a layout of all of the services that exist, so that people can discover the different services. Remember, humans are not particularly good at remembering things, but computers are great at remembering things at about 600 to 1,000 items. So how many services are there? If I'm working on a service, what services can talk to my service? What services can my service talk to? And kind of how do all of these pieces fit together? So this means no more wiki pages that are woefully out of date and unmaintained with boxes and arrows where people go in and they're like, so is this how the system still is? And someone's like, no, that's from 2 months ago. So there needs to be a real-time, preferably interactive view of your system. If you start adding to it all of these charts and graphs that I'm sure you're collecting through a lot of different types of tooling, you can have true visibility into your system and all the different pieces. And finally, if you add the interaction elements, like one-click deploy buttons, you can actually have an interactive view of your system where people can go in, deploy code out to specific services, see how that service is running, what resources that code is actually running on. So most people probably have no idea what the actual server resources that their code is running on look like. How big are they? What type of VMs are they? All that information. You can actually show it to people so that they can discover the information themselves. And finally, when in doubt, you can consult Jacob Nielsen's 10 usability heuristics. So these are still probably the best usability heuristics for developing interfaces. And remember, interfaces can be anything: an API, a programming language, a text interface, a command line console, or it can be a graphical user interface. So we covered some of these explicitly. Visibility of system status is one of my absolute favorites. Recognition rather than recall. I am not very good at remembering things, and so I usually have to lay it all out for myself. Help and documentation. So make sure that people have a place that they can go to actually ask questions and get documentation on your system. Error prevention is a big one. So preventing people like my brother or other poor engineering interns who don't mean to delete the entire user database table. Actually preventing them from deleting the user database table is far better than having a great recovery system in place, although you should have a recovery system in place as well.
So to sum it all up, we have answered these 3 questions today. What is usability? The learnability and ease of use of human-made objects. And then, why is usability important for web infrastructure? To reduce human error and increase the individual and team productivity. And finally, how do we build usable web infrastructure? We automate the core processes like deploying code and system configuration, and we expose human usable access points that make it easy for people to understand the actions that they're taking and the resulting impact on the system. So thank you, and if there's any questions, I believe we have a couple minutes.
Yes, indeed, we've got... We indeed have 5 minutes for questions, and there are 2 microphones in the hallways here, in the hall tracks. So if you want to ask a question, please line up at one of the 2 microphones and we'll get to you.
You're also welcome to just come find us afterwards if you want to talk about things.
Okay, we have a question over here.
Hi, thanks for your talk. It was very interesting. I have a specific question for you, and that is, have you had any experience with helping anyone moving from infrastructure which is traditionally based on like VMs or bare metal to containers?
I haven't specifically done any contract work with companies. I know that that is a really big question, the VM versus container question, what you should use. That, I think, is a talk in and of itself. It has to do with scoping problems, security, what you're building in the first place. I can refer you to some online resources that I think would be great for that.
No, I was more interested in like those inertial issues that usually organizations face. Like they think of the tremendous amount of effort that would need to go into just changing the way they work. But that's okay. Thanks. Can I ask another question?
No, we're going to pass it over to the person over here. If you have another question for them, come up and ask them after the talk, please. Over here.
Yeah, I was very interested in the like, you talked about the visualization of the system.
Sorry, could you please speak close to the mic? Thanks.
Yeah, sorry. I was very interested in when you talked about the visualization of the system and the health of the system. It seemed like very obviously useful. And I was wondering if there are like common tools that you recommend for that, or if those are sorts of things that have been built in-house places you've worked. Like, what are your recommendations for how to do that?
Yeah.
So one of the examples that comes to mind at Hearsay Social is that we integrate a lot with the social media companies like Facebook and Twitter and LinkedIn. And so there's a lot of questions about like integrations with their APIs and what are the cases that we cover and what are the cases that we don't cover, like due to these APIs. And so we kind of battled that for a really long time until we came up with a way of just having like a page that dynamically renders all these cases based on these APIs. And so whenever there's a question, like we just look at it right there, and there's no need to keep that up to date because it's automatically kind of surfacing whatever is available at that time. So that's one example that I can think of.
Yeah, there's also, so there's some companies that have done a really good job of implementing in-house systems. Netflix is a great example, and they've open sourced their platform, their internal like developer platform. I'm not sure how much visualization of the system that they do. I built my own because I actually don't know of any really good tools for building those visualizations, but we can definitely talk afterwards about that one.
Okay, we'll take one more question, please.
Hello, great talk, thanks a lot. So you talked about web infrastructure. What do you recommend for infrastructure which is more hardware dependent, which may have like custom requirements, for example, GPUs or something like that?
How to make the automation tooling for hardware?
Hardware-dependent applications.
Yeah. So a great start point, if you don't know where to start at all in making something usable, is the first thing you can do is reduce the number of steps that someone has to go through as much as possible. And whatever steps someone needs to go through, write a checklist. There's an entire book on checklists called the Checklist Manifesto. Checklists have made unflyable planes flyable, and they have reduced the infection rate in ICUs from 11% to 3% on specific procedures. So if you don't know where to start, start manual. Start with a checklist, because you can edit a checklist really easily, and once the process is more ironed out, and everyone's like, yes, we agree that this is the process, when you step through the checklist, things are done correctly, you can start automating. There's nothing wrong with bash scripts for a lot of stuff. Bash scripts have been working great for many years. If people are starting to get confused about kind of visual stuff, I think that's when you start to bring in a graphical interface. But that's kind of the approach that I would recommend taking.
Thank you.
Well, thanks Joyce and Kate for such a wonderful insight on applying usability to something that we might not have thought about deploying usability on. Please thank them for such a fantastic talk.
Thank you.
2:30.